geological sciences, Daniel Nance, examines the geology exposed in the Appalachians today.
What may look a rather unimpressive wall of rock to the casual eye has proven to be a geologic Rosetta Stone in this part of the Appalachians, and it records the very first collisional event in the building of the Appalachians.
These belts of folded rocks are the surviving record of 3 titanic collisions that created the mountains. Billions of years after the creation of the Akashic Tonalite, 2 ancient continents begin to collide. As these 2 continents close in on each other, the ocean floor is pushed down underneath what will become Africa. Gradually, the ocean is consumed. Huge sections of the seafloor are dumped on the edge of the continent, creating ridges and valleys. As the continents continue their inexorable journey, island landmasses are compressed between the 2. Debris accumulates, now on dry land. The continental collision forces the debris further upward, driving the Appalachian Mountains higher. It's the geological equivalent of a car crash.
If you imagine a wreck between a truck and a much smaller car, the first thing that happens when the 2 hit each other is a collision between the front of the 2 vehicles. And you can think of that as the first collisional episode in the Appalachians. The next thing that happens is the truck hits a windshield, and that, if you like, is the second collisional event in the Appalachians. And finally, the car disappears under the truck, and that, if you like, is the climactic collision, the one that produced the final collision and brought the whole process then to a close.
Back at the road site, there is evidence of the 3 phases of uplift. By dating the rocks, scientists can tell when each happened. Building the Appalachians took nearly 200 million years.
The movement of these continental masses is typically in the orders of centimeters per year, which is a very slow rate. It's about the rate your fingernails grow.
This mountain building process involves hundreds of thousands of cubic miles of rock. It's thought the Appalachians originally rose higher than the present-day Himalayas. Today, they are a shadow of their former selves, cut down to size by another powerful geological process, erosion. The mighty Appalachians were tamed by another powerful enemy, water. When water freezes, it expands in volume by as much as 8%. Here, a bottle of water rapidly freezes. The ice expands, and the bottle cracks. This same action applies to rocks. Water freezing in cracks breaks them apart. When temperatures rise, the ice melts and it washes away the debris. Wind and rain add to the process, and over eons, they have the power to utterly transform the landscape.
Erosion can do incredible damage to a mountain range, and we can see that in the modern Appalachians. The modern Appalachians are simply the remnants of this once vast and very high mountain range.
Today, Pangaea's eroded mountains are in North America. How they came to be here is the next step in the story of the continent.
Continents trap heat. Continents act a little bit like a book on an electric blanket. If you put a book on an electric blanket, it gets hot.
The book acts as an insulator, trapping
do the same thing with heat generated in the Earth's interior. And so if you put a very large continental mass together, like Pangaea, heat builds up beneath it.
Pangaea is big. It's nearly as big as all of our 7 continents put together. The temperature builds up underneath the continent and heats it up. As the rock absorbs heat, it arches. Then, at its weakest points, it cracks, including along the line of the Appalachian Range. It's a process called rifting. As Pangaea cracks, it creates